Good morning all of you. In the last session I had completed your highway user benefits and vehicle operation cost. Okay, in today's session I will move on to the next topic, that is methods of economic analysis. Methods of economic analysis. Okay, the economic analysis is done to determine the monetary benefits from the proposed additional investments. Okay, there are several methods of economic analysis. Okay, some of the simple methods are: number one, it is annual cost method. Second one, it is benefit cost ratio method. Third one, it is internal rate of return method. Fourth one, it is net present value method. Net present value method. Okay, there are four simple methods. The first one is annual cost method, second one is the benefit cost ratio method, third one is internal rate of return method, and fourth one is net present value method. Is it clear? Okay, I'll take up one by one. Okay, the first one, it is annual cost method. Okay, the annual cost CR is obtained from the relation P into I 1 plus I to the power of n divided by 1 plus I to the power of n minus 1. Is it clear? That is equal to P into CRF. CRF is the capital recovery factor. The annual cost is considered for the each economic assessment of highway projects. Is it clear? The annual cost is considered for each economic assessment of the highway projects. Okay, usually the annual cost of the capital improvement will be obtained by multiplying the capital recovery factor. Okay, the annual cost of capital improvement is obtained by multiplying the capital recovery factor CRF. Okay, it's very simple. Here CR is the annual cost of improvement, P is the initial cost of improvement, and I is the rate of interest, and N is the estimated life in years. N is the estimated life in years. Okay, this is regarding the annual cost method. Okay, sometimes, okay, at the end of some service life period of the road, some items may be assigned some salvage values. Okay, at the end of service life of the roads, okay, some items could be assigned to some salvage value. Okay, in that case, okay, you are going to calculate the annual cost using this relation, that is CR is equal to C minus Vs multiplied by I into 1 plus I to the power of n divided by 1 plus I to the power of n minus 1 plus I into Vs. I into Vs. Okay, where C is the capital cost, that is the cost of improvement, and Vs is the salvage value at the end of n years, at the end of service life of the items. Next, I is the rate of interest in decimals and n is the estimated life in years. This we can write C minus Vs multiplied by CRF, because this term I into 1 plus I to the power of n divided by 1 plus I to the power of n minus 1 is equal to CRF, no, capital recovery factor. Then C minus Vs into CRF plus I into Vs will give the annual cost of improvement if the salvage value is given for the particular item. Is it clear? Usually, okay, the annual cost for each elements, okay, will be calculated separately. Annual cost for each elements will be calculated separately. Then the total annual cost will be obtained by summing the annual cost of all the elements, okay, with annual maintenance cost. Is it clear? Means usually the annual cost of each elements will be calculated separately. Then they will obtain the total annual cost by summing up the annual cost of each elements with the annual maintenance cost. Annual maintenance cost. Is it clear? Okay, this is regarding the annual cost method. Have you understood? No? Okay. The next it is benefit cost ratio method. Benefit cost ratio method. Number 2 it is benefit cost ratio method. Okay, in the benefit cost ratio method, they are going to assess the merit of the proposed highway improvements. Is it clear? Usually the benefit cost ratio is equal to benefit cost ratio is equal to annual benefits from improvement divided by annual cost of improvement. Okay, benefit cost ratio is the ratio of annual benefits from improvement and annual cost of improvement. Okay, that is equal to, okay, R minus R1 divided by H1 minus H. R minus R1 divided by H1 minus H, where R is the annual road user cost, that is total annual road user cost for the existing road. For the existing road, and R1 is the total annual road users cost for the proposed highway improvement. For the proposed highway improvement, and H1 is the total annual cost for the proposed highway improvement, and H is the total annual cost for the existing road. Is it clear? Means the benefit cost ratio is the ratio of annual benefits from the improvement divided by what? Benefit cost ratio is the ratio of annual benefits from improvement and annual cost of improvement. Okay, it is R minus R1 divided by H1 minus H, where R is the total annual road user cost for the existing road, R1 is the total annual road user cost for the proposed highway improvement, H1 is the total annual cost for the proposed highway improvement, H is the total annual cost for the existing road. Is it clear? Okay, they will going to find the benefit cost ratio for each of the alternative proposals. For each of the alternative proposals. Okay, and for those proposals which having the benefit cost ratio less than unity, those proposals will be discarded. Okay, the proposals whose benefit cost ratio is less than 1, okay, those proposals will be discarded. Okay, usually for the justification purpose, of proposed highway improvements, okay, the benefit cost ratio should be more than unity, more than 1. Is it clear? Means for the justification purpose of proposed highway improvements, the benefit cost ratio should be more than 1. Is it clear? Okay, that is regarding the benefit cost ratio method. Is it clear? Next is internal rate of return method. Number 3, internal rate of return method. Return, that is called IRR. Internal rate of return method, that is called IRR method. Okay, in this method, okay, they are going to find the percentage of rate of return for the capital. They are going to find the percentage of rate of return for the invested cost. Okay, the percentage of rate of return R is equal to, okay, O plus A minus M divided by P multiplied by 100. Okay, where R is the percentage of rate of return and O is the savings in annual road user cost. O is the savings in annual road user cost and A is the, okay, savings in accident cost. Okay, annual savings in accident cost, and M is the average maintenance cost per annum. M is the average maintenance cost per annum. Okay, and P is the capital cost of improvement, that is investment cost. Capital cost of improvement, or you can say investment cost. Okay, whole thing multiplied by 100 will give the rate of, that is percentage of rate of return. Okay, where R is the percentage of rate of return, O is the savings in annual road user cost, A is the annual savings in accident costs, M is the average maintenance cost per annum, and P is the capital cost of improvement, and multiply 100 will give the percentage of rate of return. Okay, usually whatever the percentage of rate of return are they have obtained from this relation, okay, should be greater than the rate of return obtained from the market, that is a interest rate from the market value. Okay, then only that proposal is accepted. Is it clear? Means what they are going to do is they are going to find the percentage of rate of return for each of the alternatives, for each of the alternative proposals to fix the priority. But the thing is that for that proposal which gives more percentage of rate of return, okay, than the market value of interest, okay, those proposals will be accepted. Okay, what they are going to do is whatever the percentage of rate of return obtained from this relation, they are going to compare this percentage of rate of return with the market value of interest. Okay, then the percentage of rate of return obtained from the relation is greater than the market value of interest, then that proposal will be accepted. Okay, if it is less than the market value of interest, then the proposal is discarded. Is it clear? Okay, this is regarding the internal rate of return method. Okay, the next fourth one, it is net present value method. Net present value method. Okay, this is called NPV method. Net present value NPV method. Okay, net present value method, it is NPV 0 is equal to B0 minus C0 plus B1 minus C1 divided by 1 plus I plus B2 minus C2 1 plus I power 2 plus so on plus Bn minus Cn 1 plus I to the power of n. Okay, in the net present value, okay, they are going to compare the present worth benefits minus annual cost, okay, for each of the alternatives. Have understood? No, in the net present value method, okay, they are going to compare the present worth of benefits minus costs for each of the alternative. Is it clear? Means in this method the benefits B are treated as positives and the cost C are treated as negative. Okay, in the net present value method the benefits are treated as positive and costs are treated as negative. Okay, what they are going to do is they are going to compare the benefits, the present worth benefits minus cost for each of the alternative proposals, and the best one is the one which gives the maximum positive differences between your present worth benefits and the costs. Means the one which gives the maximum positive differences, okay, that is the best one. That is the best one. Okay, in this relation NPV 0 means it is a net present value in the year 0. Net present value in the year 0, and B1 comma B2 are the present worth benefits, or we can say benefits in the year 1 and 2 up to n year. Okay, and C1 comma C2 are the costs in the year 1 and 2. NPV naught is the net present value in the year 0 and B1, B2 are the value of benefits in the year 1 and 2, and C1, C2 are the value of cost in the year 1 and 2, and I is the discount rate in decimals. I is the discount rate in decimals, and N is the life. N is the lifespan. Is it clear? Okay, this is regarding the net present value method. This is regarding the net present value method. Okay, next I will move on to the numericals on first method, that is annual cost method. Okay, numericals on annual cost method. Okay, the first problem it is number 1, calculate the annual cost of a stretch of highway from the following particulars. Okay, the first column is item, second column is total cost in rupees, that is in lakhs, estimated life in years, and next is rate of interest in terms of percentage. Okay, here they are given about 5 items. The first is land, second is earthwork, third one is bridges and culverts and drainage, next fourth one is pavement, and the fifth one is traffic signs and road appurtenances. Okay, and for the land they are given total cost 35 lakhs and estimated years is 100 and rate of interest is 6, and for the earthwork it is 40, 40 and 8, and for the bridges, culverts and drainage 50, 60 and 8, and for pavement it is 100, 15, 10, and for the traffic signs and road appurtenances, okay, total cost is 15 lakhs and life the estimated life in years it is 5 and rate of interest is 10%. Okay. Next, here the average cost of maintenance of the road is rupees 1.5 lakhs per year. The average cost of maintenance of the road is rupees 1.5 lakhs per year. Okay, it's very simple. Okay, I'll go with this. Okay, I'll go with the solution. We have annual cost. We have annual cost. CR is equal to P into I 1 plus I to the power of n divided by 1 plus I to the power of n minus 1. Okay, where P is the cost of improvement, I is the rate of interest in terms of decimals, and n is the estimated life in years. Okay, first is annual cost of land. Annual cost of land. Okay, see here, for the land the investment cost is 35 lakhs and estimated life it is 100 years and the rate of interest is 6, means P is 35, then N is 100 and I is 6%, that is in terms of decimals it becomes 0.06. Okay, substitute it, P is 35, then I it is 0.06 plus 1 plus 0.06, okay, power 100 divided by 1 plus 0.06, okay, 100 minus 1. 100 minus 1, okay, this will give about rupees 2.1063 lakhs. This will give about rupees 2.1063 lakhs. Okay, similarly find the annual cost of next item is earthwork. Annual cost of earthwork is equal to what? Okay, for the earthwork the investment cost, that is P is equal to 40 lakhs, then N is equal to 40 years, I is equal to 8%, that is 0.08. Then substitute it, it is P is equal to how much? 40, okay, multiplied by 0.08, okay, 1 plus 0.08 power 40 divided by 1 plus 0.08, 1 plus 0.08 power 40 minus 1, okay, n minus 1, no, 40 minus 1, okay, this will give about rupees 3.3544 lakhs. Rupees 3.3544 lakhs. Okay, that is annual cost of earthwork. Similarly, find the annual cost of bridges, culverts and drainage. Next it is annual cost of bridges, culverts and drainage is equal to CO. For the bridges, culverts and drainage, the investment cost P is equal to 50 lakhs, estimated life is 60 years and rate of interest is 8%, that is 0.08. Okay, then it is 50 multiplied by 0.08, 1 plus 0.08 power n, okay, n is about 60 divided by 1 plus 0.08, okay, n is 60 minus 1, okay, this will gives about the annual cost of bridges, culverts and drainage, okay, you may get about rupees 4.04 lakhs. You may get about 4.04 lakhs. Okay, this is the annual cost of bridges, culverts and drainage. Okay, similarly find the annual cost of next item, it is pavement. Annual cost of pavement. Okay, see here for the pavement, okay, the total cost, that is investment cost, it is 100 lakhs, estimated life is 15 years and rate of interest is about 10%, that is 0.1. Okay, then it becomes 100.1, 1 plus 0.1 to the power of 15 divided by 1 plus 0.1 to the power of 15 minus 1. Okay, this will gives about rupees 13.147 lakhs. 13.147 lakhs. Is it clear? Okay, what is the next item? Next item it is traffic signs and road appurtenances. Okay, next it is annual cost of traffic signs and road appurtenances. Annual cost of traffic signs and road appurtenances. Okay, for that item the total cost in rupees in lakhs is about 15 lakhs, that is investment cost is 15 lakhs, estimated life is 5 years and the rate of return is 10%. Okay, okay, P is 15, then I is 10, no, that is 0.1, 1 plus 0.1 to the power 5, 1 plus 0.1 to the power 5 minus 1, 5 minus 1. Okay, this will gives about rupees 3.9570 lakhs. 3.9570 lakhs. Okay, these are the annual cost of all the 5 items from your land to traffic signs and road appurtenances. Is it clear? Means for each items we have to calculate the annual cost individually. Then the total annual cost for all the items will be summed up along with the average maintenance cost, then we will use the total annual cost. Is it clear? Means we have calculated the annual cost for all the 5 items. Okay, in addition to that, was there given the average cost of maintenance of the road is rupees 1.5 lakhs per year. Okay, then the total annual cost is equal to annual costs of all the items plus average maintenance cost. Okay, we have to sum it up the annual cost of all the 5 items, okay, with average maintenance cost, then will gives the total annual cost. Is it clear? Okay, total annual cost of highway, total annual cost of highway is equal to what? Annual cost of all items plus average maintenance cost, average maintenance cost. Okay, go for that. What is the annual cost of land? Okay, you may get about rupees 2.1063 lakhs, no? 2.1063 lakhs plus annual cost of earthwork 3.3544 lakhs plus annual cost of bridges, culverts and drainage 4.04 lakhs plus what is the annual cost of pavement? Okay, it is about 13.147 lakhs, no? 13.147 plus then annual cost of your traffic signs and road appendices, how much you get? Okay, about rupees 3.9570 lakhs, 3.9570 lakhs. Then what is the maintenance cost, average cost they have given? They have given the average maintenance cost about 1.5 lakhs per year. We have to add it, rupees 1.5 lakhs. Okay, then we get the total annual cost. Okay, if you sum it up, how much you get? It is 2.1063 plus 3.354 plus 4.04 plus 13.147 plus 3.9570 plus 1.5. Okay, how much you get? Totally we get about rupees 26 lakh 6049. 26.6049 lakhs rupees. Okay, it's very important. 26.6049 lakhs will get it. Okay, the annual, that is total annual cost of highway, you may get about 26.6049 lakhs. Okay, this is regarding the first problem. Okay, next we'll move on to the second problem, an annual cost method. The second problem it is number 2. The second problem it is compare the annual cost of a 2-lane road for 2 types of pavement structures. Okay, the first one it is waterbound macadam with thin bituminous surface at total cost of rupees 108 lakhs per kilometer. Life of 5 years, interest at 10%, salvage value of rupees 10 lakhs after 5 years. Okay, then annual average maintenance cost of rupees 0.35 lakhs per kilometer. Okay, and the for second, bituminous macadam base and bituminous concrete surface, total cost of rupees 197 lakhs, then life of 15 years, interest rate is 8%, salvage value of 25 lakhs at the end of 15 years, then annual average maintenance cost of rupees 0.75 lakhs per kilometer. Annual average maintenance cost of rupees 0.75 lakhs per kilometer. Okay, it's very simple. Okay, here they are given 2 different road surfaces. We are going to compare those 2 different road surfaces, okay, by using the annual cost. Is it clear? By taking the salvage value into consideration, the annual cost CR will be calculated from the relation, okay, C minus Vs multiplied by I into 1 plus I to the power of n, 1 plus I to the power of n minus 1 plus I into Vs. Okay, where C is the cost of improvement, Vs is the salvage value, and I is the rate of interest in decimals, n is the estimated life in years. Is it clear? Okay, and we know that first one, WBM with thin bituminous surface. Okay, for the first case you may observe here, what is the C value they have given? The C is rupees 108 lakhs and N they have given 5 years and rate of interest they have given 10%, that is 0.1. Then salvage value Vs they have given about 10 lakhs. Okay, for the WBM with thin bituminous surface, C is 108 lakhs, then Vs is 10 lakhs, N is 5 years and I is 10%. They only given, no? Then substitute the given values in this equation, okay? CR is equal to, C is 108 minus Vs is 10 lakhs, salvage value, multiplied by I is 0.1, okay? Then 1 plus 0.1, N is 5 years, divided by 1 plus 0.1, 5 minus 1. Okay, this will give the annual cost, okay, considering salvage value for the first condition, that is a WBM road with a thin bituminous surface. Okay, for the first case you may get about annual cost, how much it is? You may get about rupees 26.8524. We get about 26.8524 lakhs. Rupees 26.8524 lakhs. Okay, this is the annual cost of the WBM with thin bituminous surface. Okay, then total annual cost. Total annual cost is equal to what? Annual cost plus average maintenance cost. Average maintenance cost, no? What is the annual cost? It is 26.8524. And what is the average maintenance cost? They have given annual average maintenance cost. It is about 0.35 lakhs per kilometer. This plus 0.35. Okay, may get how much? The total annual cost for the WBM with thin bituminous surface, you may get about rupees 27.2024 lakhs. Okay, similarly find out for the bituminous macadam base and bituminous concrete surface. Okay, second one, for bituminous surface, okay, CR. Okay, you may observe here for the bituminous macadam base and bituminous concrete surface, C they have given 197 lakhs and N is 15 years and I is 8%, that is 0.08, and salvage value, that is Vs is 25 lakhs and the average annual maintenance cost is about 0.75 lakhs per kilometer. Okay, first find out the annual cost. Okay, it is C minus Vs, no, C is 197, Vs is 25, multiplied by I is 0.08, 1 plus 0.08 power 15 divided by 1 plus 0.08, okay, 15 minus 1. Okay, this will give the annual cost of bituminous macadam base with bituminous concrete surface. Okay, how much you get annual cost of bituminous surface? It is rupees 22.0948 lakhs. Rupees 22.0948 lakhs. Okay, then what is the total annual cost for bituminous surface? That is the annual cost plus average maintenance cost, no? Then it is 22.0948 plus 0.75 lakhs. 0.75 lakhs is what? It is average annual cost per kilometer. Then you add that 0.75 lakhs for this 22.0948, then you will use the total annual cost for the bituminous surface. Okay, then compare the total annual cost of WBM with bituminous surface. Okay, then whichever the pavement surface which gives the least annual cost, okay, that will be more beneficial. Okay, next it is total annual cost for bituminous surface is equal to what? Annual cost plus maintenance cost, no? Maintenance cost. Okay, that is 22.0948 plus 0.75. Okay, you may get 22.8448 lakhs. 22.8448 lakhs. Okay, then what about the total annual cost for your WBM with thin bituminous surface? It is 27.2024 lakhs, whereas your total annual cost for bituminous pavement is 22.8448 lakhs. No, means compared to your WBM with thin bituminous surface, your bituminous concrete surface has less annual cost. Okay, then your bituminous surface is more beneficial than your WBM road. Is it clear? That is the actual thing in this problem. You have to compare the two different pavement structures. One is WBM with thin bituminous surface, and one is the BM base with bituminous concrete surface. Okay, the BM base with bituminous concrete surface is more beneficial than your WBM base with thin bituminous surface. Okay.